All right, so thank you all for coming. This was put together on short notice. It was sort of a last minute inspiration. And I particularly want to thank Jack for upending his schedule for the week to come join us and present FairCam. Um, I'm especially interested, oops, all right. I'm especially interested in this from the standpoint that one of the real challenges in modeling, perhaps the central challenge, is abstraction. What level of abstraction, managing the abstraction. So here we have two quite different approaches to exactly that problem, that challenge. And so you all are going to hear and see different levels of how to approach cyber risk and control analytics. And I think we'll have the opportunity to go more deeply into that in subsequent forums, whatever, perhaps at CIRCON. But that I see as a sort of fundamental point of interest here. All right, I'm sort of talking to pass time since Bill is starting us off.
Okay, thank
Here's
you.
Bill.
So see, can I see? All right, this is pretty good.
Looks good.
So can everybody see the screen? My name is Bill Frank. I'm the Chief Client Officer here at Monaco Risk. And the way the agenda we have planned is that each of us, Monaco Risk and then Jack representing FairCam, will each take about 25 minutes or so, leaving a few minutes at the end for any further questions or comments. So I'm going to start by talking a little bit about Monaco Risk Control Analytics model, which we use on a regular basis as part of our cyber risk advisory services. Oops. So I like so the key problem or the rationale or the reason for a CAM is to help align cybersecurity efforts with business goals. And I kind of like this NIST CSF 2.0 figure that highlights the relationship between executives and practitioners, communications and the responsibilities. I'm not really crazy about the fact that they use the term managers as that in between level. I think it would have been better if they used CISO and risk managers. And as strong as this CSF is, it's still pretty weak in terms of how exactly to bridge this executive practitioner gap. And there's an aspect of it that's top down and bottom up as well. From a top down side, it's about defining loss event scenarios that are associated, or the way we see it, loss event scenarios associated with the business goals of the organization. Um, and that generally means the revenue producing processes, and then given a budget, how best to allocate that budget to optimize risk reduction. And on the bottom up side, you have the issue of translating control metrics that are being generated by the security team, by the controls, and translating that into changes in risk in dollars, and then also justifying potentially new additional budget requests. Now, the last thing is I'm not crazy about that risk matrix there at the top, the heat map. Our software generates loss exceedance curves, and whether they're actually used in presentations to executives, that's a topic for another conversation. The underlying driving principle for our approach to CAM is the defender's advantage. And I like to talk about this by starting with the opposite. And I still hear this too often, that this myth that defenders must be right 100% of the time and attackers need be right only once. when in reality, attackers have to execute a series of steps to achieve their objectives, and therefore defenders have multiple opportunities to block attacks using controls. And, of course, controls could be any combination of people, processes, or technologies that you have control over. Now, having said that, that does not mean this is easy to do. It's still quite challenging. And of course, it's because of the limited budget that the cybersecurity team has, limited budget, limited resources. And they're faced with an ever expanding attack surface because when you hear this hesitation, that means somebody new has just joined the meeting and I've had to stop to click on them to admit them. Anyway, so the expanding attack surface, because pretty much every new organizational initiative requires IT. The threat landscape continues to expanding even faster and more, and becoming more sophisticated due to AI. Organizations are faced with hundreds, maybe thousands of vulnerabilities. Um, Identity, access, privilege creep, and then the misconfigurations or underconfigurations of controls. So given this environment, enter MITRE ATT&CK. MITRE ATT&CK has become and is the unifying framework for cybersecurity teams. And here I have a diagram, I have a representation of the techniques and sub-techniques as dots, which are explicit in MITRE ATT&CK. What's implicit is the idea of the kill chain. That's not a new concept. It's been around for a while, Lockheed Martin back in 2011. But basically, the idea is that there are attack paths, there are threats, TTPs, that the attacker will use to move into and through the organization. And I've seen risk analysis attempt to use individual kill chains for the analysis. The reality, though, is that organizations, for any particular loss event scenario, organizations are faced with hundreds, if not thousands, of kill chains and dozens of controls associated with that. And so if you think about it, it's this complex web of nodes and edges that really are a kill graph. And that's what you have to deal with. And that's what our CAM, the Monaco Risk CAM, deals with. Now, here's I'm sure everybody's seen this, the MITRE ATT&CK matrix. This level of granularity, of course, is key, is useful for the security practitioners, but it's way too granular for risk analysis. So what we've done is we've established a higher level of abstraction where we've taken MITRE ATT&CK and broken it down into 4 stages: initial access, execution, lateral movement, and objectives. We have found the need to still break initial access down into into smaller components, and the same thing with objectives. So the next question that we have to deal with is inputs. What are the inputs that we're going to use for a CAM? And traditional control metrics, as they're gathered and used by cybersecurity teams, are really inadequate for budget allocation. There are 2 problems. The first is that they're specific to a control type. So, for example, a firewall, you're talking about the percentage of threats that are being blocked or the granularity of the policies, and compare that to MFA via SMS versus passkeys. So that's a problem. The other problem, which is even more difficult, is that controls are measured in isolation. So how are we dealing with these 2 issues? First, we translate control metrics into a standard set of input parameters. At a high level, it's capability, coverage, and governance. Capability referring to the capabilities of the control. The coverage is how is the coverage of that control across the organization, and then the governance of the control. How well is it configured? How often is it updated? issues like that. Now, the real breakthrough, I would say, for Monaco Risk CAM is how we treat cybersecurity controls, or the portfolio or set of cybersecurity controls, as a complex system that works collectively in concert. Now, in order to do that, we need additional factors besides the control parameters of capability, coverage, and governance. We've already talked about loss events of concern to business leaders. Examples, of course, exfiltration of sensitive data, business disruption due to ransomware, and several others. I talked about the kill graph, and Jim is going to show this in the demo. It's all the associated attack paths or kill chains associated with a specific loss event. Then there's threat strength range, and that refers to the different the strength of the attackers. A large financial organization is going to be dealing with nation state attackers, while a smaller organization might just be dealing with cyber criminals. And finally, the distribution of threats across attack paths. So as an example, using that first initial access stage, our default template uses 7 initial access methods: third party, network, email, physical access, etc. And what we're doing is we're assigning percentages. This is, this is threat intelligence, leveraging threat intelligence. What percentage of the attacks are coming in through these different initial access methods? And we can get this information either industry threat intelligence, or it can come, more accurate information could come directly from the SOC, the Organization Security Operations Center, or from an MDR service that a smaller organization is using. And what we're delivering is we're calculating aggregate control effectiveness using our cyber defense graph, which Jim is going to go into and then following that, ranking each control's contribution to overall risk reduction. We use tornado charts for that, and Jim's going to go into the details on that. And then finally, the actual decision support using what if scenarios for which we generate loss exceedance curves. So to kind of summarize, we've moved from anatomy to not only physiology, but also complex system analysis. And I think the reason, one of the reasons we've been successful at this is the combination of the backgrounds of Jim and myself, the 2 partners here at Monaco Risk. Jim having the strong and deep quantitative risk analysis, modeling, and I've had 25 years of cybersecurity experience. I'm not going to bore you with all the details of our backgrounds. We don't really have time for that. But to kind of summarize where we're coming from, we're about scoping risk analysis by loss event scenarios, leveraging MITRE ATT&CK, but at a higher level of abstraction, standardized control input parameters, evaluating cybersecurity as a complex system, controls and kill graphs in particular, generating aggregate control effectiveness using our cyber defense graph software, simulation software, ranking controls current and potential contributions to risk reduction, and visualizing that using a tornado chart. And then finally, what if scenarios displayed as loss exceedance curves. Okay, well, now I'll turn it over to Jim. Jim, you should be able to share your screen. I don't think I have to do anything on my side.
Okay, so thank you, Bill. Good morning, good afternoon, good evening to everyone. I'm Jim Lipkus. I'm going to show the demo of Monaco Risk's Cyber Risk and Control Simulator with Control Analytics. So And this is going to be a bit of a fire hose. There's a lot of material here. We're running a little bit behind, and even so, this was going to be this is going to be a squeeze. So, of course, we can answer questions and provide more information later in other forums and so forth. But in any event, you're looking at the home screen of the cyber risk and control simulator. You see on the left here a variety of risk types, loss event types, a couple of variants of ransomware, exfiltration, some other things. For this demo today, one loss event type is selected and in scope, and that is exfiltration by an external attacker. On the right, the impact models. And when we do have multiple risks in scope, we display the results either individually or aggregated, and that's note over here. So we're going to come back here, but for the moment, I'm going to open external data exfiltration. This is a cyber defense graph. It looks just like the ones you saw on Bill's presentation. These can be a little bit scary at first. We find that after a couple opportunities, they become quite intuitive, people with a cybersecurity background. So threats flow from left to right. You're looking, by the way, this model is inherently graphical. You're not looking at a picture or a representation of the model. You're looking at the model itself. Specifically, this is the UI of a model. The cyber defense graphs are all templates. We have templates built in for a variety of risk types. All the templates can be edited, adapted, cloned, and so forth. So, and thing to note is that as threats move from left to right, from the threat event node to the loss event node, the threat population becomes smaller and smaller and stronger because more and more of probably the weaker threats are being filtered out by the successive controls along the paths. There are thousands of paths here. This is a modular organization. I can drill down on any of these modules. I'm going to open the workstation module. This is execution. And here you're seeing specific controls, the little blue ovals, and all the different threat paths. And again, there's quite a bit of threat intelligence built into this in various respects. We're looking at the blue box here. The gray boxes are just neighboring adjacent nodes so that we can see the paths in and paths out. So threats come into the workstation from a variety of sources. Each thread is going to follow one path through the workstation. They're going to encounter the workstation agent. That's our name for the endpoint agent. A malware attack might be just a dropper that has to beacon out to its command and control site to obtain a full malware load. That's this path down here, and that's going to encounter some net edge firewall controls. Back to the workstation, the endpoint agent, following the path, log analysis, and then out. Most threats are probably going to move out. Most threats that have survived this gamut of controls are going to move out to the back end. If an attacker has managed to acquire the necessary data directly from the workstation, then the threat might move through a data authorization control directly out to exfiltration. So this is the model: threats, attack surface, and controls. We're going to run a Monte Carlo simulation against this, and there's some underlying math there. So we're going to throw a very large number of randomized simulated attacks at the model and see what happens. So what is the goal here? What is the problem we're addressing? We know that the organization is concerned about compromise of its sensitive data. We have this whole control configuration here. We want to know where the exposure is, where are the gaps, in particular, where are the critical paths. Critical paths are those paths from threat event to loss event and all the different path segments here, those paths that are being exploited by the threats that became loss events. the stronger threats, the threats that succeeded. To do that, we're going to inventory the loss events here and look backwards to see where those threats, where those loss events came through. What were their paths through the control configuration, through all these different phases. Those are the critical paths. We can display path criticality with this red color display. Ignore the bright red on pre-exfiltration. By definition, every exfiltration attack goes through the exfiltration module, so that's not very interesting. What's more interesting here, the data center has some criticality, but the most important, most interesting modules here are the workstation and identity. Let's take a look at identity. Clearly, we have a lot of attacks coming in via password spraying or credential attacks, and they're going to encounter these controls. There are only two controls in identity: authentication of entering users and authorization. Now, we have some background information here. We know that this company has MFA installed, hopefully a modern conditional MFA, but very few of their employees actually, of their users, actually have it enabled. So this control has a coverage issue, and we're going to come back and address that. In the workstation now, drill down, we can see the most critical path through the workstation is simply the endpoint agent going out through log analysis. So we could remediate that critical path by strengthening any of these controls. Which should we choose? To drill down on individual controls, we run what we call a control importance analysis. It's actually sensitivity analysis, and this is the tornado chart that Bill showed. So in order of importance, it happens the two most important controls, given all the settings and so forth for this loss event, are the authorization, authentication of entering users. That's not a surprise. There's some back-end stuff here, and then another very high control is the workstation agent. So we're going to focus on those. We're especially interested in the right-hand bars here. The right-hand bars shows the potential additional risk reduction that could be achieved by turning that control up to the max. Ideal technology or process selection, ideal configuration and maintenance, and so forth. The left-hand bar represents the current effective risk reduction, contribution to risk reduction of that control. The sum of the two is the importance. Okay, so we're going to focus on, squeezed for time here, we're going to focus on user authentication and workstation agent. User authentication we already looked at, that's a coverage issue. Let's go back to the workstation and look further at the workstation agent. Now, every control has a whole battery of inputs. The really important ones, Bill said, are capability, which is short for prevention detection capability, coverage, and governance. So we're going to go look at the inputs and think about the settings for this control. And in fact, there are some red flags here. Capability is low because this company is running an old-fashioned signature-based antivirus here. Can't detect much. Coverage, installation on workstations, that could be improved. There's a major governance issue here because one of the governance factors for an endpoint agent is frequency of software update. You want to have the current detection, or in this case, current signatures. So those have to be remediated. By the way, the low and high here, these are not ordinal levels. They are PERT range presets. We define these presets for each control. They're built into the model, and they allow huge streamlining of the setup process. Setting up the model for a new environment, all the control inputs to enter. We use these presets most of the time because the built-in PERT ranges are adequate most of the time. Those PERT ranges are visible. They can be overridden by the user. We do that occasionally, but very often we use low and high. So now we've identified a couple of issues that we want to focus on. we're going to build some candidate control improvement portfolios. Where do we want to focus our limited budget, given these critical gaps that we've identified? So for demo purposes, we created 5 what-if scenarios. Each of these represents a set of modifications to one or more inputs of one or more controls. Scenario 1 here, we're upgrading the coverage of MFA. Hopefully, most or all of the users will get it turned on. Scenario 2, we're replacing McAfee with CrowdStrike or SentinelOne or some other modern EDR. Scenario 3, we're leaving McAfee in place because it's cheap, and simply changing the frequency of software update. We're going to make it as needed, which could be multiple times a day instead of monthly. Scenario 4, we're going to combine the 2 workstation agent improvements, CrowdStrike and frequent update. Scenario 5, we're going to combine those with the coverage upgrade on MFA. And now we're going to run the Monte Carlo simulation again. Each of these is going to produce a result. We want to see how they compare. We want to assess their relative contribution to risk reduction, and then we're going to think about investment alternatives. Contribution to risk reduction, of course, is not a scalar number. It's a range. There are a variety of tools here to display that. In the interest of time, I'm going to go directly to the loss exceedance curve, which is sort of the most informative. I would click on this node here, but we're running this with a very high sample size, and that will take something like 20 minutes to compute. So I have another instance of the same model here with the loss exceedance curves already computed. Can you all see that? Are the loss exceedance curves visible? Yes, they are. Good. Okay. So you're all familiar with loss exceedance curves. So I'm not going to elaborate. At the top here, the largest loss, that's the client baseline, which is the status quo. The successive what-if scenarios then are these different colors. Some of them represent very small improvement, others represent large improvement. The combination, scenario 5, with respect to these financial loss levels, and these are very high, these financial loss levels. We'd have to look at the inputs to the impact model to figure out why they're so high. In any event, at this $400 million level, scenario 5 is reducing the overall risk, the overall probability of exceeding that level by about 1/3. So that's a substantial impact. So I want to point out that the most important use of this kind of model is interactive. Imagine the risk analyst sitting with a security architect, trying different scenarios, fiddling with the inputs, getting a look at how the inputs interact, how the control behavior interacts, threat intelligence, and so forth. And with that kind of interactive modeling, and this is an experience of the modeling and data analytics world in general, with that kind of interactive sort of playing with the model, the security architect gets a deep insight into how the dynamics of this risk and this control configuration are working. And that's extremely valuable in charting strategy, in advising business stakeholders on investment alternatives, and managing the risk in general. All right, I'm 2 minutes over here. Jack Jones needs no introduction. Jack, I'm going to stop sharing, and it is all yours.
All right, so my presentation is not going to be as polished, I'd say, as theirs. Just haven't had time to work on it this week. But I'll do the best I can. So, problem statement about what's the most effective combination of controls for scenario and whatnot. That is part and parcel of being in the cybersecurity world, right? Now, how do we best apply our resources as was already discussed? So, Faircam's primary purpose was, I never created Faircam with the intent, the primary intent of being a commercial solution. It was an attempt to accurately describe how the control landscape works as a complex system, right? Which our profession hasn't had. And so I wasn't constrained. I wasn't trying to wrestle problems of ease of use or computational load or any of those things, right? It was just, how's this problem space work and how can I best portray it, right? So I wasn't constrained by any of that. And the kind of the takeaway as I see it, and again, I've never had an opportunity to see Monaco Risk solution before, so not familiar with it. I did, Jim had email exchange mentioned that governance is sort of their abstraction of what in FairCam is the variance management and decision support domains. So, this abstraction has its pros and cons, which we'll get into a little bit. But again, neither is more right. They're just different lenses, right? They're different approaches to the problem and created with, in some degree, different intents or constraints at least. But I think it's also important to differentiate between the models and the implementation of the model. Okay, so for example, FairCam is more complex than Monaco's risk model. That's neither good nor bad. It just has implications. But the other thing I think is important to keep in mind is that how a model is implemented is different. Is a different question than the models themselves, right? So we can generally, at a high level here, say Monaco Risk is simplified, and FairCam is more complex. But how those are implemented in a commercial solution or a technological solution, there isn't anything about FairCam that keeps it from being represented visually and all that good stuff, just as Monaco Risk folks have done, right? You can do the exact same sort of graphing and user interface and reports and sensitivity analysis, and I'll talk more about that later. So let's be clear in our own minds that we can compare these things both as models and the implementation of the model. And there today, as far as I know, there is no robust commercial implementation of FairCam. Right? There are some in the works, but today there are no robust, again, as far as I know, no robust implementations of FairCam in a commercial model. So there's an opportunity to demonstrate, FairCam in the same sort of visual way that you just saw for Monaco Risk. For those, you're probably already familiar with FairCam. If you're not, the next couple slides hopefully will cover enough of what you need to know. So we know that when we have assets and threats against those assets, we have risks, so we put controls in place. But FairCam differentiates between controls that directly affect risk, either the frequency or magnitude of loss, and controls that indirectly affect risk. So variance management controls affect the reliability of other controls. Decision support controls enable well-informed decisions. And those indirectly affect risk, and their effect on risk is realized downstream. Okay, so if we looked at, again, in this scenario of data exfiltration, let's say the initial vector and method of attack is email phishing, and personnel are resistive control against phishing. And the efficacy of personnel is a function of, well, how well they've been trained. And the efficacy of training is a function of threat intelligence. And the only way we can know if, the condition of this control and how well it's working is through testing, right? So there's variance management control that detects the efficacy of a control and gives us a heads up if it's not working as intended. But then how much any of that matters is a function of the efficacy of the other controls that are also relevant to, this same problem or this same scenario, right? So we see these relationships and dependencies here. Now, this notion of variance is central to FAIRCAM controls physiology. And so there's this notion of intended efficacy, what Monaco Risk calls capability, I guess. And so if a control over time operates exactly as intended, then wonderful. But very often variance occurs and we have some frequency of variance and duration of variance, how long it takes to detect and correct a variant condition. And then you can also have a degree of variance. Now, if a threat event occurs when let's say a resistive control is in its intended state, then hopefully you're fine, probably are fine. However, if a threat event occurs when it's in a variant state, that's when you have a bad day. However, it's, the idea of a single control, being the only thing keeping you from having a bad day that's like not real. So we have this notion of multiple controls, right? So here we say a second control, and this can be, there can be as many controls as you care to think about here, all with an intended efficacy and with some frequency and duration of variance and whatnot. So here, if a threat event occurs, well, our second control is variant, but the first control isn't, so we're probably fine. Likewise here, well, the new control is fine, but the initial control is variant, we're probably fine. It's when both are variant simultaneously, when the threat event occurs, you have a bad day. And again, you can layer multiple controls, which with each layer, you get sort of a reduction in exposure. But the point is that a couple of things. First of all, there is a temporal relationship between threat events and variant conditions and your loss exposure, right? So that's the first point. And the second is this reflects a Boolean or relationship between preventative controls, right? If one or another of the controls is working as intended, then you're having some benefit from that in terms of your loss exposure. There's also Boolean and relationships between other controls like visibility, monitoring, and recognition for detection. And being able to represent these Boolean relationships is actually really important in order to accurately measure the effect of controls on risk. So just a couple of points to keep in mind. So let's look at a case study that's not associated with this exfiltration event, but just something that demonstrates a little bit more about these relationships and the application of sort of this controls physiology framework, if you will. So, and this came from a place where I was a CISO, right? We had repeat audit findings for inappropriate access privileges, which of course is bad from a risk exposure perspective, but it also represents a lot of friction, potential for friction and wasted effort, right? If you're playing whack-a-mole all the time, that's not a good thing. Did a root cause analysis, were policies and processes well-defined, had, the expectations and rationale and the process has been communicated effectively, were managers capable of following through on their responsibilities, those sorts of things, in terms of notifying that a change to access needed to take place. Well, that was true, and that was true, and that was true, which meant managers were choosing not to make this a priority, right? Which meant that the solution had to be we had to change this as a condition within the organization. So created a process of getting a weekly HR report on changes in personnel, people who were leaving or had changed roles. We'd reconcile that against change requests for access privileges. If variances were discovered, then I would send an email to the manager, and the first email they would get would be, "Hey, heads up, you have been in, you've gone through training, you are aware of your responsibilities and the importance of this, and so this is just a friendly reminder. However, if this happens again, you will get a similar email, but you're the vice president of your business line will be copied as well. And if there's a third time, the CEO will be copied. And the problem just essentially vanished when we did this, right? So people did not want to have a conversation with their executives about why they didn't do something as simple and as important as this. So again, just an opportunity to sort of treat the problem systemically. And here's sort of the decision support domain structure within FairCam. I'm not going to spend time going through this, but just to recognize that the model here is well defined. And by the way, this model, a significant part of the variance management and decision support models within FairCam are the result of a study I did like 16 years ago when I was doing independent consulting. I went into 4 different organizations from different industries, large organizations, and did root cause analyses on populations of variant conditions, control failures, and found that there were these sort of common themes, if you will, right? And the one that was actually the long pole in the tent most of the time was the incentives thing. I mean, people were aware of their responsibilities, they were capable of following through, but it just wasn't, they were prioritizing deadlines and budgets instead, right? So you need to be able to represent those sorts of dynamics in a model in order to, I think, accurately represent both what's going on and what your control improvement opportunities are. So just looking at this sort of visually back to that diagram we saw earlier, auditing showed that we had this problem with access controls. So we did the root cause analysis and instituted the weekly reconciliation and then instituted incentives, right? So we can again see sort of this relationships between the indirect controls, right? Decision support and variance management controls, and their downstream effect on loss event controls. The key insight, I guess I'd share here is, that these things, I think we all recognize and have said for years as a profession, well, policies are important and scanning and patching and all these other things that fall in decision support and variance management, they're all important. But our ability to measure them empirically, model them accurately, and make well-informed decisions about sort of the levers we can pull has been hamstrung, right? In the absence of this sort of more formal description of the problem and how it works. When we generalize these sorts of things, right, we potentially lose some fidelity and the opportunities to make sort of those key specific improvements. But there's a trade-off there, and we'll talk more about that. So, I said a few minutes ago that there are no robust implementations of FairCam that I'm aware of. Well, that's not entirely true. Several years ago, I worked with a gentleman to create a fully fleshed out implementation of FairCam. It applies all of the different functions within it. And you can configure it in a manner very similar to what we saw with Monaco Risk in terms of, defining the risk landscape of an organization, sort of a digital twin thing, with all the various attack paths and whatnot. And then you can run sensitivity analyses and all the good, cool stuff that Monaco Risk is doing, right? But that was an research platform, right? It didn't have a user. The user interface was Excel spreadsheets that set the configuration parameters and defined the assets, business assets and technology assets and the threat landscape and the controls. And the other thing it did too, which turned out to be really important, was it included, because it was an agent-based model. And if you're not familiar with agent-based models, I encourage you to look into them. A very powerful thing. At any rate, it included as agents within this the individuals, the users of systems, the administrators of systems, executives, managers, CEO, all those sorts of things. In fact, one analysis we did with this, we said, what happens if the CEO is especially risk-seeking, right? All CEOs have to be risk takers, right? But there's risk takers and then there's risk takers. And so we set this one where the CEO was especially risky in temperament, and because we because we had people in this, we had to define a model. Within this, it had to represent the effects of human networks, right? So, sort of how the crowd works, right, with different influences and how they affect one another. And so when we ran this scenario with the especially risky CEO, we found that over time, the business crashed and burned. So anyway, but it just, again, sort of another dimension of this that you probably wouldn't see in a commercial solution, because it adds a lot of complexity and computational load. But again, when we're trying to really understand how our problem space works, what this allows us to do is gain this, I would say, very rich understanding how the problem space works, from which we can make abstractions, right? We can simplify. Well, I think one of the things people oftentimes forget is that we either simplify from a deeper understanding of something, or we simplify by sort of guessing, right? And there's not a clear, bright line between those two things, but I think it's a useful, thing to keep in mind, right? Is that when we're trying to make something simpler, it's compared to what? And if we have a deeper understanding, then I think we can make better decisions about those abstractions and simplifications. And I already talked about this. So yeah, and I'll make these slides available if you're interested. So ran a hospital ransomware case study in this platform, and we had sort of a weaker control environment versus something with sort of medium control environments. And again, the differentiation was intended efficacy is variance, frequency, duration, coverage, those sorts of things. So not ordinal values. And what we found was, variance management controls, when they would fail, there was this sort of cascading outcome from that, and that resulted in really significant losses. And again, the very specific nature of FairCam allows us to identify and make adjustments. What levers can or should we pull to avoid this? As we see, and I apologize for the charts here, I could not, that project ended a couple of years ago, and I haven't been able to find all the documentation from it. So these are not the best charts from it, but they are what they are. So on the left, we see sort of the outcome from medium controls. There were 0 losses over 20 years. Essentially, the diagonal line is the average operating expenses. The horizontal blue line was the capital expenditures, and the gross losses were that on the left side, we can see were 0. On the other side, we see the weaker scenario setup. The average operating expenses were lower because they didn't have the variance sorts of controls in place that the other scenario did, or setup did. The capital expenditures were the same, but we see that the gross losses were quite different. And really what we see there is, over time, these variant conditions and poor decision support sorts of controls begin to result in cascading control failures. And then eventually you have a really, really, really bad day. Okay. Now, we had a strong setup too, but it was, from an output perspective, it turned out, the cost didn't justify the outcome, because with medium over 20 virtual years in these scenarios, we weren't experiencing losses anyway, right? So diminishing returns. So I guess to wrap this up, I want to be conscious of time. You know, all model implementations, models themselves too, but their implementations especially involve trade-offs and design choices, right? Analytic speed, computational costs, et cetera, et cetera, et cetera, right? So the FairCam research model that I just, sort of glossed over, described, analytic speed was not important. Those analyses ran for a long, long time. Computational costs, not really a consideration or concern. What we were worried about is robustness, completeness, scalability, and support for empirical measurements. Ease of use, no, it was kind of the opposite of that, but that wasn't the point, right? So the implementation that I just, again, sort of described, those were, we were interested in quality of output and the insights we could get and scalability and that sort of thing. And but if we were to create a commercial version of that, we would have to consider things like ease of use and computational costs and analytic speed and all those good things, right? So the model, the FairCam model is not inherently constrained in terms of ease of use or anything like any of those other things or reporting coolness. But it's just, it hasn't been implemented yet commercially with sort of those purposes in mind. So if you want to learn more about FairCam, I created this custom GPT. It's an expert in FairCam, and you can access it for free. Anybody can access for free. There are a couple of URLs there you can use to get at it. And if you do use it, I hope you let me know what you like and don't like about it, because I think it is incredibly powerful, and I use it every day, and I know others who are as well. So I think it has some significant potential. And again, because FairCam is intended to be this open model, there should be nothing obscure about how FairCam, what it is or how it works, right? It is intended to be an open model, right? To be poked and prodded and criticized and improved upon. The commercial implementations of it, again, will have to be making trade-offs. Invariably, we'll have to make trade-offs, again, for ease of use and computational, those sorts of things, right? And so it's up to each individual commercial vendor then of any model to decide how sort of open they are about the trade-offs and design choices and analytic assumptions and such that underlie it. So at any rate, that's my 2 cents. I hope that was halfway useful. And I guess we have a couple of minutes for Q&A.
Okay. So as Jack said, thank you, Jack. Anybody has any questions, comments? We do have a few minutes. I'll just add that obviously we wanted to compress a lot of information into a short amount of time. So if anybody, we certainly welcome the opportunity for a deeper discussion of Monaco Risk CAM. So we're happy to, you can reach out to Jim or me, and we'd be glad to go into much more detail about the details of the factors we use and the trade-offs we decided to make, and most importantly, how it might apply to your organization.
One thing I would love to see, and probably if it were to happen, it would be next year, because I would have some work to do. I would need to reconstitute that agent-based model. And actually, I've begun working on that, but it's coding is not my strength. But would need to reconstitute and update that model. And what I'd love to see is put in, do a side-by-side Monaco Risk versus, a robust implementation of FairCam, and be able to see, all right, what differences do we see, and why do they exist, and are they relevant, right? I mean, maybe the abstractions and trade-offs that have to be made in commercial solutions, maybe they're still really reasonable outputs and such. No reason to believe they wouldn't be. But I think for me, as sort of a researcher, right, I'm really curious about that, because I'm working with companies about implementing FairCam and commercial products, and these trade-offs and these sorts of things. We really do want and need to know how much they matter in terms of the results, right? So maybe sometime we can schedule, some sort of comparison of that.
I'm very interested in doing that. My only comment is I'm very interested in doing that, period. My follow-up comment to that is that it's going to be rather complex, because a lot of the choices are interrelated.
Oh, yeah.
So
No.
you establish a level of abstraction like I was talking about before, and now your approach to variance management and our approach to governance, well, those relate to the level of abstraction. That relates to what is a control? What is it? What is a control? Even that is it's not well defined. We differ in defining.
We do.
What is it? What is a direct control?
Yep, we do. I know you think of patching as a direct control, and I don't.
Yes.
Right, exactly.
So exactly, and we can explain why we think that. But these, I'm
not saying it would be easy, but I think it's worth investigating. Right?
It would be illustrative. I don't think we're going to come to an answer.
Maybe not, but even that is an answer in itself, right? It's just. If we went through the exercise of trying to set that up, and I think again, what I would want to do is I would want to say, okay, maybe we collaborate on trying to put something like that together sometime next year, and over that collaboration, we're going like, this is really just not a feasible thing to do, not in the way we're sort of envisioning it here. That in itself would be, I think, paper worthy, right? A white paper that we could say here, because the market is so nascent, and the solution providers are kind of all over the place in how they're approaching this, and because the market is so new and uneducated on the challenges and just the nature of this problem, that I think a paper like that could be really eye-opening to folks about the problems associated with analyzing this landscape. Right? It is challenging. I have a whole chapter on automating CRQ in the second edition of the FAIR book that's coming out, hopefully in December. Hopefully, that's what the publisher's telling us. But if anybody here is interested in a preview of that chapter, reach out to me through LinkedIn, and I will send it to you. But I'm just extending that to the people who are part of this call. So if this is recorded and posted on the internet, I'm not extending it to the internet. I'm extending it to the people here, right? And
we know who you are.
Yeah. So I'll reconcile any requests against the attendance here. So anyway, but I think and the intention of the intent of that chapter is to articulate the many challenges associated with trying to create a product like Monaco Risk or commercial implementation of FairCam, that sort of thing. It's kind of mind blowing. So.
Any other comments,
Yeah,
questions,
yeah, just
personal
real
attacks?
quick. I think it was fantastic presentation and just kind of a comment, I guess. I really appreciate what you guys are doing. Jack, I love the Chat GPT. Matter of fact, I've taken that and kind of created a new one.
Oh, cool.
And
New and improved.
been yeah, and the way it's not really improved. It's actually a little watered down. I'm trying to make it a little bit more practical and a little bit more understandable by folks who aren't us.
Yeah.
Um, and
Yeah.
you know that's kind of where I would love to see some of this going. I definitely
Mhm.
appreciate the academic components of all this too, but you know, in the practical world that I live in, I have to
Yeah.
be able to explain this to non-quants
Yeah.
and
Yeah.
you know how this relates to you know people being able to sell Pop Tarts in grocery stores.
Yeah. Well,
Um,
I get that, and I've had similar feedback. So it's great feedback. Um, that's why I added at the bottom of any response you get from the Chat GPT, there's the option to tell it to simplify, and it'll
mhm.
give you a more plain language version. But that may not still meet your needs. But that was the attempt. So.
Well, I'm trying to go down that path of figuring out a way to make it still useful, but
Mhm.
you know, simple enough to use. Maybe I don't know one fair scenario and some you know parametric data from a control solution to make it make sense to folks.
Yeah. Yeah.
I have a
Lots of
quick comment, if that's all
opportunities.
right.
Yeah.
I just want to compliment kind of both sides of this discussion. So, um, at CRFQ, when we started looking at kind of approaches to determining likelihood, one of the things that we went down the path of was, and continue to go down the path and continue to use, is looking at using the results, right, from actual pen tests, right, of scenarios that are aligned to scenarios, which is very much Jim and Bill. If I'm off base here, feel free, but like that's part and parcel, right, to kind of the core of the platform, which I'm a fan of, by the way.
One of the
Um,
inputs.
what's that?
That's one of the inputs. Absolutely. Yeah, that's
Yeah,
important.
the results of pen testing, and that was one of the questions
Great
asked
thing.
in the Q&A
I
in the
apologize, guys.
chat.
I was late. Forgive me.
Yeah, yeah, but
Um,
that absolutely, yes, pen
That's not
testing,
easy to do for
glitch and
those of you
attack
that have tried
simulation.
like to take pen test results and put it into that. So kudos to the team at Monaco for all the work they've done on that. That's really impressive. The other side of the equation when you look at, I mean, for me, this isn't kind of an either or, it's a both kind of question for me, I guess is my comment, right? Like, so FairCam is the platform for doing control analysis, is my way of thinking. And Monaco is a great way of using different kinds of inputs to determine likelihood. So they both are just trying to solve the same question to me at the highest level. And so I would just suggest that as people are hearing this, that they evaluate kind of them not just separately as A or B, but A and B, because I think there is an actual path there from where I'm sitting. So again, thanks for the time, guys. I'll be quiet now, and congrats to Michael and all their hard work. And Jack, you're okay, by the way. Cheers.
All right, I
Okay,
think
we're
we're
past
going
the
to
hour.
close it out at this point. Appreciate everybody sticking around for the extra time, and as in the chat, we're going to make the slides available. We'll make the video available if anybody's interested. And as I said, Jack obviously, and so are we anxious to have deeper conversations for people who want to get, get deeper into it. All right, then.
All
Thanks,
right.
everyone.
Thanks a lot.